Alright, so what we're going to do now is we're going to look at graphs already graphed on on the grid, and we're actually going to make the equations of those graphs. Now, I've written the general equation with all your transformations in here, and just to make sure everyone's on the same page, these are the numbers that we're looking to fill in. So that's where we're started. I'm going to come up with two different equations, one being a sine equation for this graph and the second one being a cosine equation. So that's what this is asking you for the same graph. So sine functions, you have to think, okay, where would sine functions normally start? Well, they start on the axis of the curve. So when you look at this particular function, you're going to have to figure out where the axis of the curve is. So let's draw it in. Okay, so there's your axis of the curve. Now, second thing you're going to need to think about for the sine function, where does it start? Just in general, if you were to graph the sine function, where does it start? Well, it actually starts on the axis of the curve. So that's why the axis of the curve is so important to your sine wave. So, sine wave starts on the axis of the curve and usually goes up first. So what point would you use? Would you use this one? This is on the axis of the curve. It goes down. This is on the axis of the curve. It goes up. So if I'm looking at this, I would definitely use this as my start point for sine because it mimics what we want. It starts on the axis of the curve and it goes up first, so we don't have to worry about reflections. Alright, so from that, you can come up with the information that you need. So we need an A value. Well, the A value is half the total height of your wave. So it's the height from the axis of the curve to the highest point. So here, it looks like it's 2 units. Okay, period, you would take 360 and divide it by k. But to find k, you would find 360 and divide it by the period length. So let's look at the period. It actually starts at negative 360 and ends at positive 360. So hopefully you can figure that out to be 720 degrees. So your k value then is a half. Alright, so the c value here for sine is your phase shift, right? So sine, the wave is starting at negative 180. So when you write that in the equation, it would be 180 degrees to the left, right? Don't just put a sign, please. I need you to write the words left or right. Alright, and the d value is the vertical translation, and it's where your axis of the curve is. Well, so the d value is 1 up. Alright, now, you also have to think of this as a cosine wave. So, where would the cosine wave usually start? Usually starts at its high point. So, its high point is right here. So, the fact that the sine wave and the cosine wave, they're all linked, okay? So I'm just going to spread this over here. The cosine wave would start and go down, and then it would come back up, right? And I know it's hard to see because you're only seeing part of it, but it's exactly the same wave. So it's still the same wave, it still has the same amplitude, still has the same period, still has the same axis of the curve, but one thing it doesn't have is the same c value. Okay, that's the only thing that's going to change when you're talking about equations of the same graph if you write it as a sine versus a cosine. Cosine usually starts at the top, and right here it's starting right on the y-axis, so there is no phase shift for cosine. Alright, so let's write these equations out. There is your sine equation. All right, you've got your amplitude, you've got the sine, that's so important to put that in there. You've got your k value, your c value, and your d value. Okay, let's do the cosine one. Okay, so there's your cosine. Again, same amplitude, now you've got cosine in there, your k value. There's no phase shift, right, because it starts where it's supposed to, on the y-axis at the high point, and then you have that extra d value. So these two equations mean exactly the same graph. One is noted as a sine wave, and the other one is a cosine wave. Okay? All right, let's move on to the next one. All right, so we're going to be doing the exact same thing with this particular function. Okay? We need to look at it as a sine wave and a cosine wave, but probably would be a good idea to put the axis of the curve in here, even though it might be extremely obvious. Okay, so first thing you can look at here, if you're looking at the a value, you have the axis of the curve at -3. Your a value here, which is your amplitude, it's only a half. All right, so to calculate the k value, it's 360 degrees divided by p. So it doesn't matter where you start, but I'm going to start at the top here and end up at the top over here. So I've got 30, 60, 90, 120 degrees. So that gives us a k value of 3. Now we have to think of this as a sine wave and a cosine wave. So if this was a sine wave, again, the sine wave starts on the axis of the curve and goes up first. Now, what I usually try to do is take the closest start point to the y-axis. Okay, so I'm going to look at this as my start point for my sine wave. It starts on the axis of the curve and it goes up first. Now, if I would have taken this point, I would have had a reflection. I could, in all good conscience, take this point as my start point, or this point, or this one, or this one. There are multiple start points, but I'm going to suggest, just to keep the numbers low for your phase shift, that you start or use the point that's closest to the y-axis. So in this case, it's going to be 30 degrees to the left. Okay? Now, the only other thing we need to look at right now is to look for the phase shift. It's gone 3 down. Sorry, not the phase shift, but the vertical translation, or where the axis of the curve is. It has gone 3 down. All right, now the other thing we need to consider is where our cosine wave would be. Okay, where the start point would be. Again, cosine starts at the top, usually right on the y-axis. And again, this one starts at the top, right on the y-axis. So I certainly would use this point versus that point or that point. Okay, there's no phase shift. You normally would, well, sometimes there's going to be one easier equation to build and one harder one. The harder one usually has the phase shift in it. So in this case, the sine wave would be our harder one. Well, let's see what the equations look like. So here would be our sine wave. Okay, we've got the amplitude, we've got your k value, we've got the phase shift and the vertical translation. And let's look at the cosine wave. So here's your cosine wave. Now, notice that you still have the same amplitude, same k value, no phase shift this time because it starts on the y-axis, same axis of the curve. All right, it's imperative that you have square brackets when you have a k value and your phase shift, but you don't really need square brackets when you don't have the phase shift, or if you have a phase shift and the k value is just 1. Okay, so if there's only one value in the brackets, you can have your round ones. Otherwise, you need square brackets.